Geometric sequences and geometric series. One example of a geometric sequence could be 1, 2, 4, 8, 16, ... where r is equal to 2. If you multiply 1 by 2, you get 2. If you multiply 2 by 2, you get 4. If you multiply 4 by 2, you get 8. If you multiply 8 by 2, you get 16. So the common ratio is constant. It is 2. A second example could be 1 minus 3, 9, 27, ... This time the common ratio is negative because if you look at the sequence, it's going positive, negative, positive, negative, and the ratio is 3. If you multiply 1 by minus 3, you get minus 3. If you multiply minus 3 by minus 3, a minus and a minus gets a plus, and minus 3 times 9 gives you minus 27. Another example could be 8, 4, 2, 1, a half, quarter, ... In this example, it is reducing, so r is going to be fractional. And if you multiply 8 by a half, you get 4. 4 by a half, you get 2. 2 by a half, you get 1. So r is a half. A final example could be minus 50, 10, minus 2, 2/5, ... Again, r is going to be fractional. If you multiply minus 50 by a fifth, minus a fifth, you get 10. 10 times minus a fifth, you get 2. 2 times minus 2 times minus a fifth, you get 2/5. So r is minus 1/5. Again, for exam purposes, in the exam formula booklet, you get a set of formulas for geometric sequences and geometric series. You get a formula to work out the nth term, any term in the sequence, and one to sum a number of terms in a geometric series. So the sort of question you might be asked to do is find the 10th term in the first series. In order to do this, you could use, or you would use, this formula, u to the n. N is equal to 10. u1, the first term, is equal to 1. And r, the common ratio, is equal to 2. So u10, the 10th term, is equal to 1 times 2 to the power of 10 minus 1. So u10 is equal to 1 times 2 to the power of 9. So u10 is equal to 512. On many occasions you will have to find r. So r is equal to u2 divided by u1, which is also equal to u3 divided by u2, which is also equal to u4 divided by u3. In general, r is equal to u to the n plus 1, any term, divided by u to the n, the term before it. So if we use the first geometric series, u2 is 2, u1 is 1, so r is equal to 2. You might also be asked to sum a number of terms, and if you are asked to do this in an exam, you would use either of one of these formulas. It doesn't matter which one you use, they're both exactly the same or give you exactly the same answer. They're just written in a different format. You might be asked to find, say, the sum of the first 5 terms in the first sequence. You could do that by just adding them up and they come to 31. But if you use the formula, S5 is equal to U1 is 1, R to the power of N, so that's 2 to the power of 5, minus 1, divided by, R is 2 minus 1, so S5 is equal to 1 times 2 to the power of 5 is 32, minus 1, divided by 2 minus 1 is 1, so S5 equals 31. Let's take a closer look at another one of the sequences, 8, 4, 2, 1, half, quarter. If you sum the first 4 terms, it comes to 15. If you then sum the first 5 terms, it comes to 15.5. If you then sum the first 6 terms, it comes to 15.75. If you then sum the first 7 terms, you'd need the next term, which would be an 8th. It would equal 15.875. If you notice, it's always going to be 15. You're just adding a little bit more each time. So if you sum the first 100 terms, it would be 15 point something. If you notice, it's getting closer and closer and closer to a specific value. And in this case, the sum to infinity would be 16. In other words, it's getting closer and closer to 16. Another formula you're given in the formula booklet is the sum to infinity. So the sum to infinity is equal to the first term divided by 1 minus r. And this is only true for a sequence where r is between -1 and 1. So we could use this formula to prove that the sum to infinity for this sequence is 16. So the sum to infinity is equal to u1, which is 8, divided by 1 minus r, which is a half. So the sum to infinity is 8 divided by a half. So the sum to infinity, 8 divided by a half, is 60. Let's look at some typical exam questions. Consider the infinite geometric series 4480 minus 3360 2520 minus 1890. A. Find the common ratio. That's easy. So A, the common ratio is u to the n plus 1 divided by u to the n. So we'll take the second term, which is minus 3360 divided by 4480. which equals, which is minus 3/4. Part B, find the 20th term. To do this, you can use this formula, u to the n equals u1 rn minus 1. So B, you want to find u20, which is equal to u1 is 4480 times r, which is minus 3/4, to the power of 20 minus 1. So u20, which you'll do on your GDC, is approximately 18.9. And part C, find the exact sum of the infinite sequence. So in order to find this, we're going to use this formula for the infinite geometric sequence. So we want s to infinity is equal to u1, which is 4480, divided by 1 minus r is minus 3/4. So s to infinity is 4480 divided by 1 minus minus 3/4 is 1 3/4. So the sum to infinity is 2560. The second type of question is a bouncing ball. A tennis ball bounces on the ground n times. The height of the bounce is h1, h2, h3 all the way up to hn. Form a geometric sequence. The height that the ball bounces the first time, h1, is 80 centimeters, and the second time, h2, is 60. A, find the common ratio for the sequence. So A, the common ratio, R, is u2 divided by u1, which in this case is 60 divided by 80, which is 3/4. B, find the height that the ball bounces the 10th time. So we want h10, which is equal to u1, which is 80, times r, which is 3/4, to the power of 10 minus 1. So if you use your calculator, h10 is equal to 6.01. C, find the total distance travelled by the ball during the first 6 bounces, up and down. Give your answer correct to 2 decimal places. So C. First, draw yourself a little diagram. So it bounces, 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 3, 4, 5, 6. So you want to find that total distance, 80, 60, etc. But notice it bounces up and then down. So in this question, you want 2 times the sum of the first 6 terms, which is equal to 2 times u1 is 80 times r to the n, r is 0.75, 6 minus 1 is 5, minus 1, divided by r, which is 0.75, minus 1. So do this on a calculator. So the total distance travelled, is equal to 526.09 centimetres. Another question. The first three terms of a geometric sequence are U1 is 0.8, U2 is 2.4, U3 is 7.2. A. Find the value of the common ratio R. So A. R is equal to U3 divided by U2, which is 7.2 divided by 2.4, which is equal to 3. B. Find the value of S8. So to find S8, we need to find S8 is equal to U1, which is 0.8, times R to the N, which is 3 to the 8, minus 1, divided by R is 3, so 3 minus 1. So S8 is equal to, use your GDC, 2624. And part C, find the least value of n such that S of n is greater than 35,000. So we want S to the n to be greater than 35,000. So we've got to find n. So U1, R to the n minus 1 over R minus 1 needs to be greater than 35,000. Substitute the values in. So we got 0.8 times 3 to the n minus 1 all over 3 minus 1 must be greater than 35,000. Simplify, so you get 0.4 times 3 to the n minus 1 must be greater than 35,000. So you use your GDC to solve for n. So n must be greater than 10.358. So make sure you answer the question. So the least value of n is n equals 11.